Hello everyone, so this is going to be the second video of our rate limiter, and in this video we are going to discuss about the algorithms and our final design of the rate limiter. So without wasting any time, let's get started and study. So our first algorithm is going to be token bucket. In this, what we have a bucket in which there is a capacity, like in this our scenario, we have a capacity of 4 tokens and there is a refiller. So refiller has a property to add like n number of tokens in a minute. So like I just wrote it down, we can add up to 2 tokens in a minute. So let's take an example. What will happen? If there are requests, will come to our rate limiter and every request will attach one token to it, and we can attach up to 4 tokens because our capacity is 4 till now. Like suppose our bucket is having 4 tokens right now, so we'll just take 4 requests in a minute, and after a minute what will happen? Refiller will work and add 2 tokens in a minute. So let's consider in our first minute what happens. First, like make a timeline on the first minute, second minute, third minute, and the fourth minute. The first minute, like if we get a 4 requests, our capacity is become 0. Now in the like refiller will going to put the capacity is going to be 2 now, and if we get like 2 requests, again the capacity will become 0, and again refiller will going to put the it approximately like 2 requests, and if we didn't get any request between 3 and 4, so again refiller will just going to fill the bucket completely to 4. So refiller is just going to add the tokens in our bucket. This is how the refillers and this token bucket going to be working. Let's understand it with a diagram. So I made a diagram here. So the request is going to come to our rate limiter if the tokens are present. Of course, we are going to accept the request and we are going to send it to our servers. And if the tokens are not present, we are just going to say 429 access limit, and we are going to deny all the requests. In that scenario, we'll just say them they are invalid. This is how token bucket going to work. Now let's discuss some pros and cons of this whole token bucket service. So the pro is allow occasional burst traffic, and the con is same. What that mean? Let's understand it. So I just put an example here. So if we say 10 tokens are accepted every single minute, and the refiller is going to provide 10 tokens every single minute, and the capacity is also going to be 10. So this is will just write capacity is again going to be 10, and this is our refill. Now what will happen? I just draw one timeline: 1 minute, 2 minute, and 3 minute. So these are my time. Now what happened? At 1 minute 40th second to 2 minute. So in this time what happened? We get 10 requests. So we got 10 requests. So in this 20 seconds I got 10 requests, and now from 2 minute to 2 minute 20 second I again got 10 requests. So if we see in this square box, in complete square box, we'll able to notice that we got total 20 requests in 40 seconds. So but we're just going to say that we need approximately 10, we have only 10 tokens in a minute, like as refiller was saying, so we cannot have more than that. But in this scenario, in our square box, we are seeing it, there are 20 requests in 40 seconds. So we are allowing a burst traffic. So this is a problem in the whole token bucket algorithm. Now, like I mentioned it in a pro also. So it is a con, like how we can do it. But sometimes we need this kind of a burst traffic. Like we need a system where we need this kind of a burst traffic. Like we will say that if this time of burst traffic is coming in our system, we don't want our system to be so resilient, to be so strict to our users that it will fall down. We have excess amount of like capacity to hold all these things. We can handle up to 20 requests. Like if there are double requests as well, we can handle it. So in that case, it's fine, I guess. So it can be a pro also because it is not making system so strict. Now come to the second scenario. There is a con of this whole system, that is of token wastage. So suppose in this scenario, like when we are discussing this example, on the third and fourth minute, we didn't get any request. Still our refiller is working and adding the tokens to the bucket. Like refiller has to work as well. Plus the tokens are also going to be putting back into the bucket, but they are not even getting used. So they are getting wasted. Every single time the refiller has to work, and these tokens are also getting wasted. So I don't think so this whole action is required or not. Now comes to the second point or the second algorithm, that is leaking bucket. The leaking bucket works with the help of a queue. So I mentioned it is implemented through a queue. Second point is request process on a constant rate. So here in our first example, we can see that these requests are coming in on the first, like in the 40 to 20 seconds. So there is no constant rate. The first 40 seconds there is no request, and in the next 20 seconds there are 10 requests that we are accepting. But in the leaking bucket, what will happen? The bus traffic will come, of course, like there are a lot of requests will come, but when they will reach to a rate limiter in our queue mechanism, then what will happen? It will process all of them in a constant manner. What we can do, we can just write some sort of a logic that in every 5 seconds, we'll just take one single request from a queue. This is how something we can do. Now, we take a request, it will go into a queue, and if the queue is full, we cannot accept the request, we'll just say no. And if the queue is not full, we'll just insert that request into our queue and we'll process it. So in that scenario, we will use a FIFO manner, the first in, first out. The first request that will come to the queue, will send it to the server, and all the other requests will going to wait. And after the first request is processed, second request, then third request. So we can just write a custom logic as well that in every 5 seconds we want to process a request, something like this. Now, what is the pro and the cons of this whole thing? The first pro of this is going to be predictable. It is very predictable. Like, we know that we are using a queue mechanism. So at whatever rate that traffic is going to come, we are just simply saying that we are going to process a request in 5 seconds. Like suppose. So if we just like open our inspect panel or anything on our browser, we able to know that like if I'm hitting the 10,000 APIs, still the reaching all the APIs that are reaching to a server are in 5 seconds. So it becomes very predictable for the user as well that the request will reach in every 5 seconds to our system. But like, is it harming our system? But still, someone should not know this thing. Now, second is constant behavior. I mentioned it in a pro, like a constant behavior. Sometimes we needed a constant behavior of a system. Like we don't want to allow the bus traffic. We need our, like there are some services that are saying that we can just take simply one request in 5 seconds and we only want to work with this flow. There can be a very good example for it. Like suppose you are playing a game BGMI. So what happened in it? Like suppose if I'm pressing a firing button, like I play 3 fingers, so I'm pressing a firing button and on the other finger I'm pressing crouch button and I'm performing multiple action. I am moving from here and there. So these all the actions should be performed in a specific manner. So what will happen? We'll just put all these action into a queue and then we need a constant action to be performed. Like first crouching, then this, then this, then this. So we need a constant behavior, and what we'll say, every action will perform after 0.0002 milliseconds. So whatever actions I'm performing, they will just go into a queue and they are performing an action, something like this. So this can also be used in video calling. This can also be used in video streaming. Like suppose we are putting so much data in our video streaming, but video streaming is showing everything in sequential manner in a constant bit rate, and this is how we can use this leaking bucket. This can be a pro of the system. Now let's discuss about the cons. Like suppose there is the IPL match and I mentioned CSK versus Mumbai Indians. So what will happen in this scenario? Our system will not be able to hold that lot of traffic, not be able to hold this burst kind of traffic. So this is how this leaking bucket will fail in this scenario. But it is very useful in the constant behavior. If we need it in our system, it's very useful. Now comes to the third point, that is third algorithm, that is fixed window counter. So in the fixed window counter, what we'll say, we'll just store a timestamp. So I just draw one timeline from 10 to 20. So of every 5-minute time frame, I will say that counter is going to be 3. So what will happen? So like from 10 to 10:05, if we see in the first image, there it can be like we are accepting the 3 requests. I put tick on them. On the 4th request, we'll just simply say cross. Like in this limited window, we can only accept up to 3 counts. Now there's a problem in this whole window, and that is, so here I mentioned 10:05. It is the same problem that we have faced in our first point of a bus traffic, that is before 10:05, like here like it is 10:04 and here it is 10:06. So in this whole time frame 10:04 to 10:06, we got 6 requests because 3 requests can be accepted between 10 to 10:05 and other 3 requests can be accepted from 10:05 to 10:06. So it means that we accepted 6 requests in between 10:04 to 10:06. So within 1 minute or 2 minutes, we accepted lot of requests that we can, again, in the case of a bus traffic, and we're allowing it. Can be used when the system can handle all this, but like in the scenario where our system is not able to handle double load, so of course our system will crash. So this is the pros and cons of this fixed window counter. Now I mentioned here a point, don't forget Redis. So if we have to write this algorithm, how we can write it down? So of course we're storing all the data in our Redis. So I write a small algorithm here. Let's understand it. I'm just making my page small so that it can be easily visible to all of you. Now, if the rate limiter function will take user ID, service name, and request time. Now we have to take the current value that is stored in the Redis. So what we'll do, we'll just go redis.get service name bracket like underscore user ID. If we're using the distributed Redis, we can go to our service Redis and then we can just figure out our user ID. I just make an example service name underscore user ID. What we'll figure it out, if current max time is less than our request time. So we know that we have a whole time frame. If our request time is less, like though in our like Redis we can store like a max time and min time. In this scenario, what will happen? So when there is a max time and min time, if our request time lies between us, suppose we get a request from like in a Redis there is a value stored from 10 to 10:05, and the request time if we get is going to be like suppose 10:04, then what will happen? We'll just say counter plus plus counter plus plus. We are just going to increment the counter in this scenario. But as our request time is going to increase, it is going to be increase from 10:05 to 10:06. In that scenario, I called one function get time range. What will happen in that scenario? Get time range, what will we do? Will, of course, we increment the counter 1 here when the time is time 1. So the get time range will give you a value from 10:05 to 10:10. And again, it is going to store in our Redis. So our Redis is going to look like this. This is our user ID. In the first time, the Redis will contain a tuple of, so first of all, it will contain our min time, that is max time, and our counter. These are the three values Redis is containing. And when the get time range function is calling, in our first scenario, the time range is going to be 10 to 10:05. And whenever the else part is going to trigger, the value is going to change from 10:05 to 10:10. This is how our sliding window will work. And at the end, I return current count greater than limit. If in the specific time range, if it exceeded the limit, and of course, we are going to say that this is going to not work. Now comes to the fourth approach, that is of sliding window counter. So now let's understand the sliding window counter. It is a hybrid algorithm that combines of fixed window counter and sliding window log. So sliding window log means that there is a log moving out every single time. Like the first log is going to be like, assuming in my scenario, it is going to be 1 minute, and I mentioned 1 minute 1 second. So we can, if we take an example, so our logs are not going to be directly moving from 1 minute 1 second next, then the next log is not going to be 1 minute 1 second and 1 minute 2 seconds. No. It is going to be 1 minute and 10 milliseconds to 1 minute 1 second to 10 milliseconds. This is how our log is going to move. So if I consider the log, it is going to look something like this. This is our first log and this is our second log. This is our third log. This is our fourth log. This is our fifth log. So our bucket, these are our buckets. Previously our buckets was, when we are using fixed window counter, these are our buckets. So now our log is moving in a specific, in a small time frame that increases our accuracy. So in this scenario, when our first, like the capacity is 2, in our first block, we are saying it can accept 2 requests. But now here, let's see the other example. In this 1 minute and 2 seconds, when we are on this block, we are accepting the 2 requests. When there is a request come here, like in between after the 2 seconds, but there is a log. It is saying that I cannot accept the third request. So this log will say I cannot accept 3 requests in this time frame. So this is how sliding window counter will work. So it is a combination of both fixed window counter and sliding window log. How to implement this logic? We have to implement this logic with the help of a linked list. And this whole algorithm will take O of n time to perform. It is slow, but it works pretty well and saves the system. So suppose if I get a request at 1 minute, so we just make our head like this. This is the head of our system, head of our linked list. Our linked list was empty. We just added an entry. Now, if we get a second request in a particular time frame, like let's assume our range is 60 seconds. Okay, so if I minus 20 seconds from like 1 minute, then it will give you simply 20 seconds. It's in the range. Then we will allow this entry. So we have allowed this entry. Now there is an entry. Now there is no API call for next like 50-60 seconds, and we got our next API request at 1 minute, like 1 minute, 1 second, 40 seconds. So that will give you approximately 100. I wrote it down 100 seconds, but it is going to be 100 milliseconds. So simply now it will give you, if we take out the difference from this parameter and the first parameter, we'll able to know, if we like take out the difference, we'll able to know 100 seconds. So we know that it is more than our range. The range is of 60 seconds. So what we are going to do, we'll just remove the first head element of our linked list. Again, we take out, now we are going to check with our 20 seconds parameter. If we know again that like it is more than 60 seconds, then again we are just going to remove that value. Now our new head becomes this 40 seconds parameter. This is our new head. Now comes to the fourth point, like if we get a request after like 10 seconds, at like 50th point we get a request, again it is less than our capacity, so we are just going to increment in our linked list, and it is less than 60 seconds, so again we are just going to put it in our linked list. Now at the sixth point, can you see what we are going to do? Now if we get a request after 10 seconds more, so it is less than 60 seconds and capacity is more than 2. So should we allow it? Like capacity is only 2, so we cannot take this entry. So we will say no entry because capacity is 2 and we cannot allow this request. This is how it is going to work. Now let's understand the coding part of it. What we're going to do, we'll just figure out, like we'll just take out a linked list from our Redis. So we'll just pass our user ID and service name to our Redis, and it will give you a linked list, and the linked list stores the timestamps. And again, what we are going to do, we'll just figure out the cutoff time. The cutoff time, we figured it out, was 60 seconds. We already know that. I just calculated request time minus window size. Now, if we traverse a while loop, we'll check if the cutoff time is like we know that the cutoff time is of 100 seconds. So we'll just wrote it down that if it is more than 60 seconds, we can just simply wrote it down. We can just store it in a configuration level as well. If it is more than 60 seconds, what we are going to do, we'll remove all the elements from our linked list till the time we find an element and that is less than 60 seconds. So we are just popping those elements. If we figure it out that the result is less than the if we figure it out that there is a capacity now to insert the element, we are going to return true, and we insert our element. And if we figure it out there is no capacity, our capacity is completely filled, so we'll say false. We cannot accept your entry, or we cannot accept your request. We'll just say invalid. This is how the sliding window counter will come. Now comes to an edge case of this algorithm. Like I already told you that we are using a linked list. So if we are using a linked list and if we got a request at the same time from two users, so what will happen? So there will be two heads will generate. So this will create a chaos. So linked list is not able to understand where to go now because there are two heads. It should look something like this, but it is looking like this now because of two requests came at the same time. So we need some kind of a locking on the linked list. So for that in Java or like in an implementation, when you do it, you can use a concurrent linked list instead of a linked list. Now comes to the final part of this video in which we are going to make a design. It is going to be very easy. When the request comes to a load balancer, I mentioned there is a cache in our load balancer. Now after that it will reach to our rate limiter, and there is a distributed Redis behind the rate limiter that will figure out that the request will be processed or not. And on the basis of the algorithms that we have discussed, we'll use one of the algorithm according to our use cases. And then if the request is going to be valid, we'll just send it to a server. And if it is not valid, we'll just not send it to our server. This is a very simple design of a rate limiter. So thank you for watching me, and let's meet in the next video where we are going to study some interesting topic. And bye bye.